Myself Girish P from Sri Venkateswara College of Engineering. Today I am discussing about bearing capacity of soil. Introduction to bearing capacity of soil. Bearing capacity is the ability to soil to support the loading applied, understanding the crucial for building stable foundation. When construction any structure, it is essential to access the bearing capacity of the soil. The assessment assemble involving evaluating the soil ability to understanding the weight of the building and any additional load that have applied to it. By determining the bearing capacity of the soil, engineers can ensure that the foundation to design the safely distribute the load and prevent settlement of failure. Factors such as soil compaction, composition, moisture content, and compaction played a significant role in determining a soil bearing soil capacity. Importance of bearing capacity. Essential for stability. Adequate bearing capacity ensures structures are supported and remain intact. Prevents settlement. It is high bearing capacity prevents excessive settlement of structures over time. Factor in design. Engineering calculation rely on accurate bearing capacity data for safe design. Factors affecting bearing capacity. These are essential factors that can affect the bearing capacity of soil. One of the most important of these is soil type. Different types of soils have different characteristics such as density, porosity, and shear strength, which are impact their ability to support loads. Another key factor is the depth of the soil. The deeper of the soil, the greater it begins bearing capacity since deeper layers are typically more compacted and have fewer voids. Additionally, the presence of water in the soil can also affect bearing capacity. When soil is saturated, it has become weakened and less able to support loads. Soil composition. The type and arrangement of soil particles significantly impact bearing capacity. Water content. Excess water reduces bearing capacity due to increasing pore pressure. Depth. The deeper the soil, they have higher the bearing capacity due to greater confinement. Types of bearing capacity. These are various types of tests that can be conducted to determine the bearing capacity of soil. This test has engineering axis the soil ability to support different types of structures and loads. One common type of test is a plate load test. In this test, a large steel plate is placed on the ground and the known load is applied to it. The settlement of the plate it is measured allowable engineers to calculate the bearing capacity of the soil. Another test that is frequently used in the cone penetration test. In this test, a cone-shaped probe is pushed into the ground. Their resistance to penetrate is measured. This resistance can provide valuable information about the soil bearing capacity. Plate load test measures the pressure requirement to cause a specific penetration of the plate into the soil. Cone penetration test employs a cone-shaped tips to measure soil resistance and axis bearing capacity. Calculation methods for determining bearing capacity. Terzaghis bearing capacity theory, analyzing the stability to footing based on soil shear strength parameters. Mayov's bearing capacity equation. It considers the impact of surcharge load, soil cohesion, and angle of internal friction. Hansen's bearing capacity equation. It is the focus of the effect of soil inclination and depth of the bearing. Common failures modes of soil under loads. Settlement. Excessive compression causes progressive sinking of structures. Shear failure. The soil loses its strength loading to sliding of the structure. Liquefaction. Under cyclic loading, soil temporarily loses strength due to increasing pore water pressure. Design consideration of foundation based on bearing capacity. When designing foundation for structures, it's important to consider the bearing capacity of the soil. This is based on bearing capacity determines how much load the soil can support without experiencing excessive settlement of failure. One key design consideration in the size and shape of the foundation. The foundation should be designed to distribute the load evenly across the soil, minimizing the rise of differentiation settlement. In addition, the foundation should be sized appropriately for the expected loads, taking into the account factors such as weight of the structure and the focus that will be applied on it. Another important consideration in the depth of the foundation. The deeper foundation can provide greater bearing capacity, but it can also be more expensive and difficult to construct. In many cases, composers must be stuck between bearing capacity and construction cost. Finally, it's crucial to consider the characteristics of the soil itself. The soil type, moisture content, and other factors can all impact bearing capacity, and these factors must be carefully evaluated to ensure that the foundation is designed appropriately. Challenges and limitations in axis bearing capacity. Accessing the bearing capacity of soil can be a challenging and complex process. These are many factors that can impact the behavior of soil, and these factors can be difficult to predict or account for. One major challenge is in the variability of soil properties. Soil can exhibit significantly variation even within a small area, and this can make it difficult to accurate axis bearing capacity. In addition, soil properties can change over time due to factors such as weathering, erosion, or compaction. Another challenge is the difficulty of obtaining representative soil samples. Soil samples must be carefully collected and tested to ensure that they are representative of the soil condition at the site. However, that can be difficult due to factors such as soil heterogeneity, depth, and the presence of obstructive. Risk assessment. Difficulties in forecasting potential soil behavior under varying loads. Accuracy. The variability of soil properties and the limitations of predictive method pose challenge. Safety factors. Accounting for uncreational in the calculation and applying appropriate safety factors. Conclusion and key takeaways. Throughout this presentation, we have exploring a range of topics related to we have covering a lot of grounds and hopefully provided how with a solid foundation for understanding the complexities of the field. So, what are some key takeaways? First and foremost, it is crucial to approach with the open mind and the willingness of learning. This is a constantly evaluated field and there always more to discover, explore. Another key takeaways in the importance of by focusing on we can this help us understanding the bearing capacity of soil. The fundamental is ensuring the stability and safety of structures. It involves a comprehensive assessment of multiple factors and rigorous testing procedures. Thank you for watching.